All right, this video is going to talk a little bit about the basics of trigonometry. And basically in trigonometry, it kind of comes down to angles to start with. So this video is mostly going to talk about different types of angles. Now you see we've got a few different angles on the screen. Hopefully you're familiar with degree measurements. So you'll notice that we've graphed 4 different angles in standard position. The standard position of an angle in math is when the vertex, or where the initial side and the terminal side come together, where the vertex is at the origin. That's a standard position. And again, our initial side is also going to be the positive x-axis. You'll notice in each of these graphs, the red line is the positive x-axis. So 30 degrees is just 30 degrees literally up from that axis. So between the red and the blue lines, that would be considered a 30 degree or approximately a 30 degree angle. Now, you might know that 390 degrees, of course, is just 360, so a full circle, note the blue line here, plus another 30 degrees, right? 390 minus 360 would be 30. Well, that makes those two angles coterminal angles, and we'll talk more about that in a little bit. But because they end in the same place, that would be coterminal. They have the same terminal side. Now, also, if you have a negative angle, just remember that you're going to go clockwise. Note the other two angles here, we went counterclockwise. A negative angle, we would go clockwise from the positive x-axis. So I'm going down into quadrant 4 and looping around that way. And then 900 degrees, again, the same idea as that 390. If we actually took 900 degrees and subtracted 360, in fact, a couple of times over, we would end up with 180 degrees. Right? 720 plus 180 would have been 900. So again, we just looped around a couple of times. Make sure you show those loops, right? Show the loops. Otherwise, that might just look like a 180 degree angle. But if we loop around, we have to follow the loops. That tells us we went 2 full rotations plus another half a rotation in order to achieve 900 degrees. All right, let's talk some more about fine-tuned details here. So when we're looking at degrees, we can also measure angles in radians. So just remember that 180 degrees, again being a semicircle, if we chop that into 3 parts, basically we would be saying that that's 60 degrees, 120 degrees, and of course ending up at 180 degrees over here on the left. Well, what if we don't want to count by degrees? What if we want to count in what we call radians? Now, radians are just a measurement, right? They're just a measurement of the length of the arc on a circle divided by its radius. Or basically 1 radian is the length of 1 radius laid along the edge of the circle. So if I could pull a string right along this edge of this circle here, right, that radius, and I could lay it down right along the edge of that circle, the length of this line, right, the radius, and the length of this arc right here are exactly the same. That's 1 radian, right? Which means that if I measure a couple of different radians along the way, right? Technically, that actually wasn't 1 radian because that one's not perfectly measured. We know that a half circle, remember, is pi radians, right? It has to be the semicircle. If my radius were 1, right, we would say pi r squared for the area. We would say 2 pi r, right? 2 pi r is a full circumference. 2 pi r would be a full circle. So if 2 pi times 1 is the full circle, well then half of that is pi. Very simply. And if we chop pi into 3 parts, basically pi over 3 ends up equivalent to 60 degrees then. So this first measurement would be pi over 3 radians. Or if we went 2 of them, this would be 2 pi over 3. Or if we went 3 of them, 3 pi over 3 is the same thing as pi. Now that same idea works. If we chop 180 degrees into 4 parts, these would each be 45 degree angles, or basically 45, 90, and 135. Well, if you chop pi into 4 parts, again, now this is pi over 4, right? Same thing as 45 degrees. Where we used to be 90 degrees, this would be pi over 2 radians. And where we used to be 135 degrees, we would be pi over 4 times 3, right? We'd be 3 pi over 4 radians. The same idea works over here at the right, where this used to be 30 degrees. That would also be equivalent to pi over 6 radians. Or you could count 2 pi over 6, or basically pi over 3, right? Same thing as this 60-degree angle over here. Again, 3 pi over 3, or 3 pi, sorry, over 6 would be pi over 2 radians. And you just keep working your way around, right? This would be 2 pi over 3 and 5 pi over 6 if you work those fractions. Again, radians just chop a circle, right, into multiple parts. But you're just talking about sort of those fractions. There's 6 fractions of pi in that first half circle. Let's move on to something a little bit more important. How about talking again, though, with that standard position? If we want to sketch a lot of angles, right, in standard position, what we can do is just sort of chop those parts. Again, we know that 90 degrees is a perfect perpendicular, right? And 180 degrees would be that perfectly straight line. And I know 130 is essentially 40 degrees, almost halfway, right? Almost halfway. Halfway would have been 45 degrees. But 130 degrees would be from the positive x-axis around that direction. Well, 240, again, same idea. I would think, okay, well, 240 is 180 plus another 60, right? If I think about it, 180 degrees plus 60 degrees would be 240 degrees. So let's go negatively, so we're going to go backwards. 180 plus another 60, right? Not quite 90. But I would put us right about there, and that's a pretty good plot of negative 240. Again, 3 pi over 4, well again, pi, right, is a half circle. So if we chop that into 4 parts, 1, 2 being the 90-degree angle, and 3, right, the fourth one would have been pi, 4 fourths is pi. Well, 3 pi over 4 then, right, is essentially 45 degrees or so into that second quadrant. 5 pi over 6, again, same idea. Let's chop it into 1, 2, 3 sixths, again, is perfectly 90 degrees. 4 and 5, and we're going to be 5 pi over 6. We're going to be out this direction, right? Pi over 6, remember, being 30 degrees, so we're about 30 degrees short of 180 this time. Same idea goes, 11 pi over 6, lost my division bar there, but 11 pi over 6, well, hey, 6 goes into 11 a full time, so that's going to be a full half circle. And then, really, that's just another 5, right? That's 5 past 6. So again, if we chop it into 6 parts, 1, 2, 3 being halfway, 4, 5, we're basically going to be right here. We are essentially 1/6 short of 12 sixths, right? 12 sixths being 2 pi. So we're 1/6 short of a full 2 pi, a full circle. And then finally, 4 pi over 3. Well, again, if we chop that into 3 parts, again, I'm going to skip that middle line this time because I want 1/3, 2/3, 3/3 takes me here. So we're talking in 60-degree increments, right? Pi over 3 being 60 degrees. So again, I'm going to go 1, 2, 3. I'm actually going to go a fourth one right down here, which basically takes us around to that point. 4 pi over 3 being 4 increments of pi over 3, 4 increments of 60 degrees. Essentially the same thing as 240 degrees, right? 4 times 60. Again, the more you work with radians, the more comfortable you'll become. So again, remember to keep your initial side on the positive x-axis and rotate counterclockwise, right, through quadrant 1 and up and around, unless you're dealing with those negative angles, right? Then we're going to go clockwise around our axis. Hopefully that helps you graphing in standard position. We're going to go over a few other topics in a follow-up video, things like coterminal angles, things like complementary and supplementary angles. So make sure you watch the next video and have a great day.